I am going to discuss on function. Function is the most fundamental concept for learning calculus and algebra. So you have to clear the basic idea about function. Let's start. Suppose you have two equations, y equals to x squared and y equals to root x. Here the solution set for y equals to x squared is, for x equals to 0 you get y equals to 0, for x equals to 1 y equals to 1, for x equals to 2 y equals to 4, and so on. Here also for the solution set for y equals to root x is like y equals to 0, x equals to 0, y equals to 1, x equals to 1. We take the principal value of square root. For sorry, this is x and this is y. For x equals to 2, y equals to root over 2. For 3, root over 3 twice value. Now see, we always take x is a positive real number. If we take negative real number, then y belongs to complex family. As root over minus 2, for x equals to minus 2 we get y equals to root over minus 2, and this belongs to the complex family or imaginary number, but we are in the real family, hence we do not check the negative value for x. Okay, in these two functions or solution sets, what we understand about the given two equation, what we understand the given equation, see, there definitely exists some relation between x and y, and also you see that here we put the value of x, first, and we get y for each x. So you can say that y is depends on x, isn't it? So we can say that y is nothing but made up with x. Y is made up with x. Okay, now think about a story of a machine. Suppose here this is a momo making machine or momo maker. If momo maker exists also, let us assume this is a momo making machine or momo maker, what it may call. Here we see that we put all ingredients like maida, oil, water, cabbage, garlic, onion, etc. into this section, and after some times of few seconds we get vegetable momos, delicious vegetable momos here. Momo for your breakfast. Now see here, we have three stages here. The first stage is the ingredient we put into the machine. The second stage is the machine works for momo, and we collect this momo into a box. So there are three stages: number 1, number 2, and here number 3. Now you see that this machine works like a function also. You may say, what? Yes, see, y equals to x squared. What we put the value of x, and y, what we get the value of y. You put 1, you get 1. You put 2, you get 4. You put 3, you get 9. You put 4, you get 16. Just like a machine. Okay, now you also notice that momo machines functionally works only for momo. It can't make sweets or juices or chocolates or any other foods. Only it makes momos only. Hence, you may assume that there exist some rules into this machine which makes momo. Now, what is rule? You may seem that rule is nothing but a methods or relation or correspondence between any two or more quantities or entities. Okay, now you cannot input anything you like into this function, as we cannot input fruits into momo maker to get juices, right? Hence, for every function there are some restrictions. What is a restriction? The restriction is to input something, what to input into the functions. So we must define the input areas. These input areas are called domain. For momo maker machine, the input domains are milk, fruit should not exist in the domain, but while maida, water, cabbage, onion, garlic, salt must contain. Now what momo maker do? It makes food. Let's list out some foods: chocolates, sweets, juices, and momos also. There are some items of foods we listed out. Now see this in a diagram. Here you see the diagram of foods: sweet, veg momos, juices and chocolates. And on the left hand side, you see the ingredient of our momos: maida, oil, water, cabbage, garlic, onion, ginger, salt, and here is the momo maker. Now what you see? You see that maida, oil, water, cabbage, garlic, onion, ginger, salts are all poured into these machines, and you get only veg momos. You can't get sweets, juices, and chocolates. You only get veg momos. Okay. Here there are two domains: the ingredient domain and the food domain. And also there is also a domain which is veg momo. This is a special domain. Why special? Because this veg momo is made under this machine only, and the sweets and juices and chocolates are different, but they are all into the food domain. Here the rules is this machine. This machine is a rule, and in mathematics we establish these rules as f. Remember, f is a rule in which maida, oil, water, cabbage, garlic, onion, ginger, salts are transformed into veg momo. Remember this. Okay. Here the ingredient domain in mathematics, we called this section is domain, only domain. And the food domain part, we call this as co-domain. Okay, co-domain, you must remember. And this particular veg momo, this box is range. What we say is the range set. Hence you clear that the co-domain is greater than the range. Now if we exclude sweets, juices and chocolates, then under food domain there exists only veg momo, and hence the co-domain part and the range part are equal. Okay, hence we establish a sense. It is clear that range is less or equal to the co-domain of a function. Range is also for the function, and co-domain is also for the function, and domain is also for the function f. We call this rule as function. Clear? Hence, a machine like momo maker is nothing but a function. Now, for y equals to root over x, in R, remember, in R, the domain. If we take x belongs to R, we get some complex number which is not under R. Hence, we can't check x belongs to only real, but we must take y belongs to positive real, that is non-negative real number, and this is the value of x. So, for this relation or equation, what we may call the domain set is R plus. Then what is the co-domain set? Co-domain set is all R. Is all R correct? Definitely you may say all R, but you can't get any negative value. Do you get a negative value in this function if you put real R, positive real? Do you get any negative real? No. Hence R plus. Or if you write R, this is not a serious error for you answer. Okay. Therefore, the function is a rule in which there are some predefined domain. Okay, predefined domain. The domain is the main important areas here. We take each x from domain and we else y, specific y, which is unique upon some relation. Then y is called a function of x. We write this concept as y equals to fx. Y equals to fx. We write this as a concept. Look, here it is clear that the variable x is independent with respect to the rule under the rule f, and the variable y is dependent on x under the rule f. Okay. Today's discussion is just like the functions and the basic idea, and here it is. Okay.